All right, let's take a look at standard form and how to graph it. So in this function, we're actually given it in vertex form, and they want us to write it in standard form. So step one is to recognize that squaring something really means to multiply it by itself. So I'm really doing x minus 3 times itself twice. Then I'm going to multiply x minus 3 by x minus 3 using the distributive property, which I like to represent in a box just to help me visualize it. X times x is very important. X squared. X times x is x squared. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3 times negative 3 is 9. So I can replace x minus 3 times x minus 3 with x squared minus 6x if I combine those two negative 3x's together, and a positive 9. From there, I'm going to want to distribute my 2 into the parentheses, which is going to give me 2x squared minus 12x plus 18. And then very last step, have to combine those two like terms. And so I'll put it in the answer box. My answer is f of x equals 2x squared minus 12x plus 19. So again, we started in vertex form and we ended in standard form. For this one, they want us to find the vertex of the function. So first we want to identify a, which is the number in front of x squared, the number in front of x squared, b, which is the number in front of x, and c, which is the constant. And I always include any negative or subtraction signs as part of my value. So for this, a is positive 2, b is positive 12, c is negative 1. And so I'm going to take my formula, negative b over 2a, and use it to find the x coordinate of my vertex. So b is 12, and I like to say opposite of b. So the opposite of 12 is negative 12. And then a is 4, so I have to multiply that by 2. So it's really it's really negative 12 divided by 4, which is negative 3. So the x coordinate of my vertex is negative 3. To find the y coordinate, I'm going to take this function, and anywhere that I see x, I'm going to put in parentheses the x coordinate I just found. So it's 2 times negative 3 squared plus 12 times negative 3 minus 1, which I'm going to quickly put into my Desmos calculator using the parentheses and everything. And I got negative 19. So the y coordinate of my vertex is negative 19. So same thing. I'm going to take this function and identify a, which is the number in front of x. There's a negative sign, but no number. So that implies that it's negative 1. I'm going to take the negative sign and include it with my b value. And same thing with the c value. I'm going to take the negative sign and include it with my c. So a, we said, is negative 1, because there really is an invisible 1 there. B is negative 2. C is negative 8. So since a is negative, the parabola is going to end up opening downwards. So it's going to point this way. So my vertex, I need to use the formula opposite of b over 2a. So the opposite of b, that's going to give me the x coordinate. The opposite of b is 2, and then over a times 2. So 2 times negative 1 is going to give me 2 divided by negative 2, which is negative 1. So the x coordinate of the vertex is negative 1. To find the y coordinate, I'm going to take this function, and where I see x, I'm going to put negative 1 in parentheses. So it's negative parentheses negative 1 squared minus 2 times parentheses negative 1 minus 8. So I literally just rewrote this whole function, but instead of x's, I put parentheses around the x coordinate I just got. So if I put that into my Desmos, I do negative 1 squared minus 2 times negative 1 minus 8, I'm going to get out negative 7. So my vertex is negative 1, negative 7. So I'm going to go 2 x values above that in the table and 2 x values below that. And I'm just going to use Desmos. So if I plug in negative 3, I get out negative 3. If I plug in negative 2, I get out negative 6. Oops, sorry, I forgot my negative sign. If I plug in negative 3, I'm actually going to get out negative 11. If I plug in negative 2, I'm going to get out negative 8. And I can mirror those values over. So negative 8, negative 11. And so if I graph that, I'm at negative 3, negative 11. That's going to just go right off the graph right there. Negative 2, negative 8, negative 1, negative 7, 0, negative 8, and 1, negative 11. And that's going to be my parabola. And then the last one, I'm given a word problem. So the height h in feet of a dolphin as it jumps out of the water can be modeled by the function h equals negative 16t squared plus 32t, where t is the time in seconds after the dolphin leaves the water. So they're giving me the values to plug into my function. So they gave me 0. So literally in Desmos, I'm going to type negative 16 times 0 squared plus 32 times 0. And that's going to give me 0. Then I'm going to plug in positive 0.5 squared. And when I do that, I get out 12. So now I'm taking the same function I just put into Desmos and putting in 0.5 for x instead, or for t rather. And that gave me 12. Then I'm going to replace t with 1. And let's see what that gives me. If I plug in 1 for t, I get out 16. Then I can, actually, I'll plug in 1.5 and get out 12, and plug in 2 and get out 0. So I can see that the dolphin's highest point is going to be 16 feet. And actually, let's graph it so we can see it. So 0, 0, half, 12, 1, 16, 1.5, 12, and 2, 0. So this is the dolphin starting at the water, jumping up into the air, and coming back down. So that's why I said the maximum height was 16. 16 was the highest it got out of the water. And it started in the water at 0, and it landed back in the water at 2. So it was in the air for a total of 2 seconds. So the time in the air was 2 seconds because it started out of the water at 0 and landed back in the water at 2.